In our last section of Chapter 9, we're going to look at our final conic section, shape, which is the parabola. Now, we've studied parabolas before throughout algebra. We've studied quadratic functions. We know that it has something to do with an x squared. Today, we're going to approach parabolas in a different way than we ever have before. Starting with a definition, a parabola is the set of all points in a plane that are equidistant from a fixed line called the directrix in a fixed point called the focus that is not on the line. Let me show you a picture of that. If we look at this basic parabola shape here that we're familiar with, this is our focus. It's opening towards our focus, and then here's the directrix on the other side. And we're saying that every single point on this parabola is in equal distance from that focus point and this directrix line. This is what the standard forms of the equation of a parabola look like when the vertex is at the origin of 0, 0. So notice how we have the x squared, which we've seen before. And what we're also going to see today is another version of a parabola equation that involves a y squared. In each of our diagrams here, so notice how the parabola shape that we're familiar with that involves the x squared, this type of parabola with the x squared can actually open upwards or downwards. The new parabola shape over here is a parabola turned on its side, and so it can open to the right or to the left, and notice how it has the y squared here. And for our parabolas, the distance from the vertex to the focus, when we measure that distance is called p. So unlike the ellipses and the hyperbolas, we used c to represent the distance from the center to the focus, but today the vertex to the focus is p. Now p shows up in the equation right here, so that 4 is always part of the equation. Whatever 4 is being multiplied by, that will be the distance from the vertex to the focus. Now there's one final thing that we're going to label in these two diagrams that helps us to determine how wide or how skinny this parabola shape is going to open, and it's called the focal width. So the focal width is a distance that passes through the focus, and it goes from one endpoint to another endpoint. So I'm just drawing in the focal width here, and the way to find the length of the focal width is to take the square root of 4, I'm sorry, not the square root, the absolute value of 4p. And again, that 4p is the number that's in the equation. So the absolute value, it turns negative values positive, and it keeps positive values positive. All right, so let's take a look at a sample equation. We have y squared equals 4x. We're going to start by rewriting the standard form, y squared equals 4px. And we're going to see here that in this equation, 4p is equal to 4. And if we divide both sides by 4, we get p is 1. So remember, p is the distance from the vertex to the focus. Now, since this is a y squared parabola, this is one that's going to open up to the side. And since the p value is positive, it's going to open up toward the positive values, and so it's going to open up to the right. Now the vertex is 0, 0, so we'll start with that. Let's do our focus, one space to the right. Now the directrix is going to be one space to the left. So the directrix is the same distance away from the vertex, but it's in the opposite direction. And then the last thing that we need to draw our parabola is the focal width. So we know the focal width is the absolute value of 4p. So in this case, the absolute value of 4 is 4, and that's going to pass through our focus. So starting here at our focus, we're going to go up 2 units and down 2 units and draw our parabola shape through the vertex through both of those end points. So see, if we measure the entire focal width here, it is a distance of 4. The last two things we're going to do, we're going to do the equation for our directrix line. It's a vertical line passing through -1, so we have x equals -1, and then we're going to write our focus as an ordered pair. Our focus is 1, 0. All right, let's try another equation. So we have a y squared equation again, so it's again going to be a sideways parabola. Now this negative sign here is going to cause the p value to be negative, and that's going to make this open up in the opposite direction. It's going to open up toward the left, toward the negative values. So if we compare this to the standard form, we see that this time 4p is equal to 12, and negative 12, and divide both sides by 4, giving us p is negative 3. So our vertex is still at 0, 0. We're going to do our focus 3 spaces in the negative direction, and so the directrix will be 3 spaces in the opposite positive direction. And the focal width is the last thing we need to get our parabola drawn. It's the absolute value of 4p. So in this case, that's the absolute value of negative 12. So that turns it into positive 12. So starting here at our focus, we're going to count up 6 spaces. We're going to count down 6 spaces. So that full length there is 12. And then we're going to connect the endpoints through the vertex. The directrix is the equation x equals 3, and our focus, the coordinates of the focus, are negative 3, 0. In this next problem, we'll see that sometimes we have to do an additional first step before we start to do our graphing, and so the standard form, we just want it to be an x squared with nothing out in front of it, and so we're going to start by dividing both sides by 2, giving us x squared equals 4y. Now, this is an x squared in our equation, and so the parabola is going to go open upwards or downwards. Since the 4 over here is positive, that means that our p-value is positive, and so our parabola is going to go open upwards toward the positive direction. If we look at the 4 here, that is in the place of 4p in the standard form. So in this case, p is 1, so it's 1 space away. The focus is 1 space away from the vertex. So we're going to do our vertex here again at 0, 0. P is 1, so we're going to go up 1 space for our focus because it's opening upwards. The focus is going to be on the inside where it opens, and our directrix is going to be 1 space below. All right, now the focal width is the absolute value of 4p, so it's the absolute value of 4, which is equal to 4. So going here to our focus, we're going to do 2 spaces to the right, 2 spaces to the left, and connect through our points. The equation for our directrix this time, it's a horizontal line, so the equation is y equals negative 1. And the coordinates for our focus, now the focus is a y-intercept, so our coordinates are 0, 1. In this next equation, to turn this into the standard form, first we need to subtract 4y from both sides. So we get the x squared by itself. Now we have the x squared again, so we know that that's going to be our traditional parabola shape opening up or down. But because we have this negative sign here, we're going to have a negative p-value, so it's going to open downwards toward the negative direction. So in this case, 4p is equal to negative 4. Divide both sides by 4, and we get p is negative 1. We're going to do our vertex at 0, 0, go down 1 space for the focus, and go up 1 space for the directrix. The focal width is the absolute value of 4p, so the absolute value of negative 4 is 4. Start at your focus, go over 2 spaces in each direction. So our focal width distance is 4. This time, the equation for our directrix is y equals 1, and the location of our focus is 0, negative 1. Now we're going to try a couple where we are working backwards. So in this problem, it gives us the location of the focus, 9, 0, and the equation of the directrix, x equals negative 9. We know the vertex is going to be halfway in between the focus and the directrix, and it's going to open up towards our focus. So just doing a rough sketch, not taking into account the focal width, just kind of get a general idea of what this is going to look like. It's going to be opening to the right. So it means that the standard form is going to be based on the y squared version of the standard form. So starting with y squared equals 4px, P is the distance from the vertex to the focus. So in this problem, P is 9, and it's a positive 9 since it's opening toward the positive direction. So our equation is y squared equals 36x. Let's try this next one. So this time, the focus that they give us, it is a y value, negative 15. And our directrix, somewhere up here, is the horizontal line y equals positive 15. So our vertex is going to be halfway between the two at 0, 0. This one is going to open downward. It's going to open toward the focus. So because it's downward, it's going to be based on the x squared version of our equation. P is the distance from the vertex to the focus, and since it's in the negative direction, P is negative, negative 15. So our equation we get x squared equals negative 60y. All right, next we're going to look and see what happens if the vertex is not at 0, 0. So the vertex can move around, and very similar to what we did for the ellipses and the hyperbolas, the only change in our standard form of our equation is we're going to introduce in the x minus h and the y minus k. Since the vertex is just simply h and k, by putting that minus sign in there, it's going to cause the sign to switch to the opposite sign. And here's what the version would look like for the x squared version. And notice how the 4p, in both of them, the 4p is out in front of a quantity in parentheses so that we can see the shift. So let's try one where the vertex is not centered at 0, 0. So for the x value of the vertex, we want to look at the number that's in the quantity with the x, so that's positive 2. We're going to turn it to negative 2. The y value of our vertex is negative 4. So let's plot our vertex. 4p is 12. That's still that 12 out in front, and so p is 3. And because it's a y squared equation and p is positive, it's going to open to the side, but it's going to open toward the positive direction. So from our vertex, we're going to count 3 spaces over to the right. And then for the directrix, we're going to go 3 spaces behind it to get a vertical dotted line. This one is actually passing through negative 5. All right, the focal width is going to be 12. The absolute value of 12 is 12. So from our focus, we're going to count up 6 spaces, count down 6 spaces. So from one endpoint to the other, it's a length of 12. And the equation for our directrix is x equals negative 5. And the coordinates of our focus are 1, comma, negative 4. Here's another one where the vertex is at a new location other than 0, 0. So the x value of our vertex is negative 2. The y value of our vertex is also negative 2. 4p equals negative 8 this time, so p is negative 2. It's an x squared equation, and p is negative, so it's going to open downward. So let's plot our vertex. We're going to go 2 spaces down for the focus, 2 spaces up for the directrix. The focal width this time is going to be the absolute value of negative 8, so that's positive 8. From our focus, we're going to count 4 spaces to the right and 4 spaces to the left. I'm going to connect our points through there. And the equation for the directrix line is now y equals 0. It's right on top of the x-axis. And the coordinates for our focus are negative 2, comma, negative 4. Now we're going to work backwards again. So given the vertex and given the focus, we are going to figure out the standard form of the equation. So let's plot the points that they've given us, 5, negative 2, and 7, negative 2. So let's go ahead and put in our directrix. It's going to be 2 spaces behind. All right, so it looks like it's going to be opening to the right. It's sideways opening, and so it's going to be based on the y squared version. The vertex is not at 0, 0, so we're going to do the y minus k squared 4p times the quantity x minus h, and just start to fill in these pieces. So for the k value, k is negative 2, so y minus negative 2 is y plus 2. H is 5, so we have x minus 5. And p is the distance from the vertex to the focus. So p is 2, so 4 times p is 8. So the focal width is 8. So if we were to continue to make an accurate sketch of our graph, we'll go ahead and make a focal width of 8 and show the parabola right there. The last thing we're going to look at is how we can convert an equation to standard form by completing the square. So this is going to help us more easily graph something that is in this general form. So to start off, notice how the x is the variable that's being squared. So we're going to keep the x squared and the 6x on the left side. Leave a little bit of space before your equal sign. We're going to move everything else to the other side. So we have minus 8y minus 8. So we're going to complete the square on the x. So we've got 6 divided by 2 squared. It's going to require us to add 9 to the left side. So to keep this balanced, we've got to add 9 to the right side. Factor the left into x plus 3 squared. We have negative 8y plus 8. Now the only other thing we need to do on this right-hand side is we need to factor out the number that's in front of the y. We're going to factor out the negative 8. That is going to represent the 4p in this equation. So when we factor it out, we're left with y minus 1 on the inside. Now if we were to go to make a graph, the coordinates of our vertex are going to be negative 3 in the x direction, positive 1 in the y direction. 4p is negative 8, so p is negative 2. P is negative, and it's an x squared, so it's going to be opening downward. So from our vertex, we're going to go down 2 spaces. Our directrix will be up 2 spaces. And then the focal width is the absolute value of negative 8, so the focal width is positive 8. So we're going to count over 4 spaces, 2, 3, in each direction. All right, so we can say the equation for our directrix is y equals 3. The coordinates of our focus are negative 3, negative 1. All right, we're going to look at one last problem where we're going to turn our equation into standard form by completing the square on the x. So we're going to keep the x squared and the 8x on this side. We're going to move everything else to the other side. Completing the square, we're going to do 8 divided by 2 squared. So we're going to be adding a 16 on the left side, so we've got to also add 16 on the right side. So to factor the left, we've got x plus 4 squared. On the right side, we have 4y plus 8. And then we're going to factor out the 4 in front. So this is the answer for the standard form. Now to graph our parabola, the coordinates of our vertex are negative 4 in the x direction, negative 2 in the y direction. 4p is 4, so p is 1. Since p is positive and it's an x squared, this parabola is going to open upwards. So our focus is going to be 1 space up. Our directrix is 1 space down. And the focal width is the absolute value of 4p. So the absolute value of 4 is 4. From our focus, you're going to go 2 spaces to the right, 2 spaces to the left, and connect our points. And we can label the equation for our directrix, y equals negative 3. And the equation, not the equation, the ordered pair for our focus is going to be negative 4 comma negative 1.